What's up, Math Brainiacs? Welcome back to Arithmophilia. Don't forget to subscribe. Let's go. Today's lesson is all about the concept of arithmetic sequence. Specifically, its definition and how to determine the missing term of a given sequence. But before that, let us be guided of our objectives for today. The following are the objectives that we need to achieve at the end of this video tutorial. First, define arithmetic sequence. Second, find the missing terms of an arithmetic sequence, and lastly, solve a real-life problem involving arithmetic sequence. Okay, without further ado, let's now start our discussion, starting with the definition of arithmetic sequence. What is an arithmetic sequence? An arithmetic sequence is a sequence where every term after the first term is obtained by adding a constant called the common difference. This can be both increasing and decreasing depending on its common difference. Looking into our table, we can say that an arithmetic sequence is increasing if its common difference is a positive number, like in the given sequence, 5, 9, 13, 17, and so on, which is being increased by 4. On the other hand, when the common difference is negative, we say that the arithmetic sequence is decreasing. Example, 20, 17, 14, 11, and so on, that is being increased by -3. Moving on, in solving the missing terms of an arithmetic sequence, we will be using this formula. A sub n is equal to a sub 1 plus the quantity of n minus 1, times d, where a sub n is the missing term of the sequence, a sub 1 is the first term, n, which is the total number of terms, and d as our common difference. I hope we are all clear with the definition and formula of the arithmetic sequence. This time, for us to better understand this concept, let's consider the following examples. Example number 1, what is the 10th term of the arithmetic sequence? 0, 4, 8, 12, 16, and so on. In solving this problem, we will be following 3 steps. First, we need to determine the value of the common difference by just simply taking any number from the sequence except the first term and subtract it by the previous one. For example, we have 16 minus the previous term, which is 12, and their difference is 4. Please take note that all the difference must be the same, because that is the special characteristic of an arithmetic sequence. Next, we have 12 minus 8 equals 4, 8 minus 4 is equal to 4, and 4 minus 0 equals 4. Therefore, the common difference is 4. Let's now continue with the second step of our solution for the first example. This time, we need to identify all the given values. Going back to our sequence, we have a sub 1 equals 0, dn equals 10, because that is what we are looking for, and d is equal to 4, which is based from our previous step. For our final step, we will substitute all the given values to our formula and start solving. So, the formula, a sub n, is equal to a sub 1, plus the quantity of n minus 1, times d. Substituting the given values, we now have a sub 10 is equal to 0, plus the quantity of 10 minus 1, times 4. Simplifying this, we can get a sub 10 equals 0, plus 9 times 4. Next, we will multiply 9 by 4. And finally, our answer for this problem is a sub 10 is equal to 36. Therefore, the 10th term of the given arithmetic sequence is 36. Is it understood? I hope it's yes. Let's proceed to our second example. What is the 8th term of the arithmetic sequence? 9, 4, -1, -6, -11, and so on. A decreasing one, right? Meaning to say, our common difference here must be negative. Let's see. Following our 3-way step, let's now determine our common difference with the following solutions. Starting with -11 minus -6 equals to -5. Why -5? As you can see, our operation there is subtraction, and it is being followed by a negative number, which is -6. Therefore, negative times negative will give us positive 6. So, we now have -11 plus 6. Applying the laws of integers, since they are unlike signs, we need to subtract them, and copy the sign of the bigger number. With this, we have -5 as the difference. Next solutions, -6, minus -1 is equal to -5. -1 minus 4 equals -5. And 4 minus 9 is equal to -5. Therefore, our common difference is -5. For our given, we have a sub 1 equals 9, n is equal to 8, and the value of our d is -5. Substituting all of these to the formula, we can now have a sub 8 is equal to 9, plus the quantity of 8 minus 1, times -5. Let us now simplify this one. We have a sub 8 equals 9, plus 7, which is from 8 minus 1 above, times -5. Next, this will become, a sub 8 is equal to 9, plus -35, as we multiply 7 by -5. For our final answer, we now have a sub 8 equals, -26. Therefore, the eighth term of the given arithmetic sequence is -26. Are all these clear, Brainiacs? Okay, let's continue with our lesson. This time, let's us ponder on this question. How can knowledge on arithmetic sequence will help us solve real-life problems and make our decisions? Let's go and see. For our application, a certain company have constructed an auditorium, with a total of 15 rows of seats. If it is 18 seats on its first row, 22 seats on the second row, 26 seats on its third row, and 30 seats on the fourth row, how many seats are there on its 15th row? In solving this word problem, we don't need to count one by one all the seats on the 15th row. You can now use your newly learned knowledge on arithmetic sequence by applying our three-way steps. Let's start, Brainiacs. For our solution, considering the arithmetic sequence, 18, 22, 26, 30, and so on. We have our common difference of 4, with the following solutions. 30 minus 26, equals 4. 26 minus 22, is also equal to 4. And 22 minus 18 equals 4. Next, we have the given values of 18, as our first term. N is equal to 15. And the common difference is 4. Let's now proceed to our final step. Step number 3. Substituting all our given values to the formula. We now have, a sub 15 is equal to 18, plus the quantity of 15 minus 1, times 4. Simplifying this, we can get a sub 15 equals 18, plus 14, times 4. Which will result to, a sub 15 is equal to 18, plus 56, as we multiply 14 by 4. Now, for our final answer, we have a sub 15 is equal to 74. Therefore, there are 74 seats on the auditorium's 15th row of seats. Finally, we have already defined arithmetic sequence, solved for its missing term, and applied it in a real-life scenario. Finally, we are now done with the lesson for today, Brainiacs. I hope that you have understood arithmetic sequence very well. Good job, Brainiacs. Before ending this lesson, please take note of this. For you to measure your previously learned understanding on arithmetic sequence, you can answer the 15-item test that I have prepared for you on my quizzes.com account. How? Just click the link in the video description below. Enjoy, Brainiacs. This ends our lesson for today. Thank you for listening, Brainiacs. See you on our next episode.